Hello, my name is Christopher Lee,
Hello, I'm William Key.
and we're excited to present you our research from this past spring quarter on mathematical modeling of past U.S. elections.
So our research has been motivated by the key questions of, can we use mathematical modeling to forecast elections, as opposed to, say, the more common statistical or political science methods? And how do different states and the voters in those states influence each other? For example, how affiliation with parties and voter opinions might spread between states, as well as how early can we make accurate forecasts? For example, how does the accuracy of our forecasts change in March or June as opposed to in November? So our final goal is to to forecast the 2020 presidential elections. But to get there, we first backtest our model on earlier elections, in this case, the 2004 and 2008 presidential elections, to determine our accuracy and help inform us as we move forward.
So in terms of the mathematical methods within our model, we've broken down into 3 steps. The first is formatting the data that we use in our model. So for our model, we use polling data, which is really good at reflecting public opinion for an election. However, it does have some challenges associated with it, such as a lot of variance between different states. So some states have more polling data than others. And furthermore, the further out from an election you are, the less polling data there is to use. The first step is handling that situation and formatting it using MATLAB. And then the next step is, once we've formatted that data, to adjust our model for each election. So we do this by fitting parameters, and you can see that we have the equations in the bottom right is what we use to forecast the election. So that second step is adjusting the parameters in there to reflect the influence between different states in our model. And then the final step is using our model that we've adjusted for the election to actually forecast the election. So we generate 10,000 forecasts using stochastic differential equations, which pretty much reflects the rate of change of the system. So looking at the rate of change of public opinion, and then using that with the association of noise, which is kind of shaking our data to make it to account for uncertainty that we have with our polling data to generate different elections.
So as a result of those 10,000 simulations, for example, we can see in this left graph that these are the electoral vote results for each simulation. And we can see that in 2008, our models did generally lean Democrat, which is something we know came true. And in this graph on the right, we can see the accuracy of our 2008 forecasts in different months. So for example, in May, we only used polling data up until May to make our predictions, and our accuracy for swing states especially was quite low, but that's related to the states not having much polling data so early in the election cycle. And meanwhile, from around August, you can see that our accuracy stabilizes, and for all states in total, we predicted about 90% of them correctly from that point on. So states having various amounts of polling data is definitely something that we had to write code to be able to handle with MATLAB. And as well as that, we also had to consider uncertainty from polling data. And we did that by introducing noise related to state demographics.
So our goal moving forward with our research is looking at the 2020 election. So we would like to forecast those elections starting this summer. And in order to put out those early forecasts, we need to understand our confidence in those. And for that, we're looking back at past elections to see how confident we were if we had run the election model in the summer. So that's our future plan with this. And we really appreciate you guys all for listening and appreciate any comments or questions below. Thank you.